Welcome. Welcome to Presto, you got it, where we use insightful comments and analysis to make your learning easy, interesting, and fun. Most importantly, our insights will help you truly and deeply understand what you want to learn. Very crucially, we emphasize important concepts multiple times in a seamless way so you can appreciate, consolidate, and internalize all these important concepts. In addition, on academyforadvancedstudy.com, at very affordable price, we offer many tutoring programs to help you. Specifically, we offer tutoring programs on SAT, ACT, AP, all the college prep materials. And of course, we cover many K-12 subjects. We even cover college level material. Furthermore, again at very affordable price, we also cover advanced topics in statistics and computer science. We also cover programming and engineering. If you want to go to medical school, we can help you too. Again, at very affordable price, we offer tutoring program for MCAT. Now, let's go back to our talk today. In our session last time, we talked about the building a simple linear regression model for our dataset. Our dataset is our studied and the test score. What we did last time was that we were able to build the linear model, and we also calculated the slope and intercept for the regression line. What we have here is a slope of 6.12 and the intercept of 50.33. This is actually quite close what we built when we generate the data. Let's take a quick look of that initial theoretical base trend. So what we have here, the second line here, true scores equals 50 plus hours multiplied by 6. This is our base trend. On top of that, we added some noise, so we have something interesting to study. So as you can see here, our theoretical true score base trend has a intercept of 50 and the slope of 6. And it's very close to what we determined through the data analysis. So in the data analysis, again, we have a slope of 6.12 and the intercept of 50.33. So our linear regression model works. Of course, not perfectly. We also computed the correlation coefficient R. What we have here is a 0.939. So it's quite good, very good, 0.9. And so we have a very strong linear relationship, as you can see from the plot below. We also calculated the coefficient of determination, R squared. What we have is 0.88, so almost 88% of the variability in test score can be explained by our study. So what else do you want to do? Study, study, study. If you study more, you will get higher grade. Come on, take a break. We know you study very hard already, so let's take a break here and take a look at some code we use to produce the plot here, and also actually the regression line here. So this is a code we have 4 lines of code. It's not that difficult except the first line. So let's take closer look of this code cell here. So we have a nice presentation here just for your code. So we have 4 lines of code. The first line we have SNS being a Seaborn library, and we use a regplot method, and we supply several parameters. The first one is that data equals df, df being the dataset data frame we produced at the very beginning of our program. That's our data contains the hour studied and the exam score. And x equals hours studied. So this is actually the column name for our studied variable in the data frame df. So what we're seeing here, x equals hour studied, is that we want to use our studied column in that data frame df as the x-axis. And the next part, y equals score on exam. What we're seeing here, very similarly to what we did for x-axis, is that we were saying we want to use the score on exam column as the y-axis. Next part, ci equals none. Ci stands for confidence interval. None meaning we are not going to produce confidence interval shading around the regression line. Sometimes it helps, but sometimes we don't want to do that. So here we're saying we don't want that confidence interval shading. Next part, line underscore KWS equals color red. So what we're saying here is that we want color red for that regression line we're going to draw, and we don't want the default blue line. Next one, so we finish the most difficult line. It's not bad. And so we move on to the second line of our code, plt dot title. So with this, we set the title of this plot, regression line colon hours versus score. This is a standard way to name your plot. So third line, plt.grid true. What we're seeing here is that we want that background grid, so make it easier for us to determine the value of the points. Plt here is the matplotlib library we imported at the very beginning. Plt.show, finally we are going to show the plot. So let's take a look at the nicer presentation with all the details, just to give you some opportunity to further consolidate what you just learned. So again, what we are seeing here is that we explain the code block we just finished, and so this piece of code creates a scatter plot with a regression line to visualize the relationship between our studied and the exam scores. The first step, what we did is to use the Seaborn SNS regplot method. So we supply several parameters. Data equals df. The source of our data is in the df data frame. X equals hour studied. That's a column in df for the x-axis value. Y equals score on exam. That's a data column in df we want to use for y-axis value. Ci equals none. As we talk about, this disables the confidence interval shading around the regression line, so the plot looks cleaner. Last part, line KWS equals color red. with this, we change the regression line color to red instead of the default blue. The result is that we got a scat plot of our data points plus the fitted linear regression line. Life is good. And that's the first line, or first step. Second line, what we did is a PLT the title regression line. Our first score. With this, we use the title method to set the title for our plot. Third step, plt.grid true. With this, we turn on the background grid lines for better readability. Last step, final line, with plt.show method, we renders and displays the plot in our notebook. That's all we do here. And in plain English, this code takes our dataset, plots each student's hour studied with score on exam as dots, fits a straight red regression line showing the trend, and formats the plot with the title and the grid. Let's go back and take another look of our regression line in our scatter plot. As we can see, this line fits pretty well with our data points. And that's all we have today. And remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, we offer at very affordable price many tutoring programs to help you. So that's all we have today. Thank you and have a great day.